If your AWS VPN goes down and your failover takes 90 seconds instead of 10, you're probably missing one critical BGP configuration that takes 30 seconds to fix.
Okay, that sounds painful. What's the difference between 90 seconds and 10 seconds of downtime?
Hey everyone, welcome back to the Network Ninja Cloudcast. I'm your host, and today we're diving into something that catches so many people off guard.
Hey everyone. Yeah, I've been setting up VPN connections and honestly, I just assumed AWS handled all the failover stuff automatically.
That's exactly the misconception we're tackling today. AWS gives you the tools, but if you don't configure them right, you're flying blind during an outage.
So what's the actual problem here? I set up my Site-to-Site VPN. I see two tunnels in the console. Isn't that redundancy?
Here's what happens in the real world. Your primary tunnel fails. Maybe there's a hardware issue at an AWS endpoint or an ISP problem. Without proper BGP dead peer detection, your on-premises router might keep sending traffic into a black hole for up to 90 seconds before it realizes the tunnel is dead.
90 seconds. That's an eternity for production traffic.
Exactly. I worked with a financial services company that was losing transactions during failover events. They had both tunnels configured, thought they were protected, but their BGP hold timer was set to the default 90 seconds. Every tunnel hiccup meant customer-facing outages.
Okay, so walk me through how this actually works. What is BGP dead peer detection?
Think of it like a heartbeat monitor between your router and AWS. BGP uses Keepalive messages, by default every 30 seconds, and a hold timer of 90 seconds. If your router doesn't hear 3 consecutive Keepalives, it declares the peer dead and withdraws those routes.
So the hold timer is 3 times the Keepalive interval?
Exactly right. Now here's where AWS gives you a superpower. When you create a VPN connection, you can download the configuration file, and in there you'll see AWS recommends setting the BGP hold time to 30 seconds with a Keepalive of 10 seconds. That's in the AWS documentation for Site-to-Site VPN.
So we go from 90 seconds to 30 seconds just by changing that timer?
We can do even better. AWS VPN tunnels support BFD, bidirectional forwarding detection, which operates at the millisecond level. BFD runs alongside BGP and can detect failures in as little as 300 milliseconds. When BFD detects a failure, it immediately tells BGP to tear down the session.
Wait, so BFD is like a faster heartbeat running in parallel?
Perfect analogy. BGP is checking every 10 seconds, but BFD is checking every 100 to 300 milliseconds. The moment BFD sees 3 missed packets, it triggers BGP failover. Your total detection time drops from 30 seconds to under 1 second.
That's incredible. So how do I actually enable this?
On the AWS side, BFD is enabled by default on VPN tunnels. That's been the case since 2020. But here's the catch. Your customer gateway device has to support and enable BFD too. If you're using a Cisco router, you'd configure BFD under your BGP neighbor statement. For a Palo Alto, it's under the BGP peer configuration. The AWS VPN configuration download actually includes device-specific instructions for this.
So both sides need to agree to use BFD?
Correct. BFD is negotiated between peers. If your on-premises device doesn't support it or has it disabled, you fall back to BGP timers alone. That's why I always verify BFD is actually established by checking the tunnel details in the VPC console. You'll see a BFD status indicator.
What about the actual failover to the second tunnel? How does that work?
This is where BGP AS path selection comes in. Both tunnels advertise the same routes to your on-premises network. By default, your router will prefer one tunnel based on various BGP attributes. When that tunnel's BGP session drops, the routes are withdrawn, and traffic automatically shifts to the surviving tunnel.
Does AWS prefer one tunnel over the other?
AWS treats both tunnels as equal cost paths. The preference is determined by your customer gateway. Most people configure AS path perpending on the backup tunnel, making its path look longer, so traffic naturally prefers the primary. When primary fails, the backup's routes are the only ones left.
Got it. So what are the mistakes you see people making?
Number 1 is not configuring both tunnels at all. I've seen production environments with only one tunnel established because someone thought one was enough. AWS explicitly states in their documentation that you should always have both tunnels up for redundancy.
That seems obvious, but I can see how it happens.
Number 2 is leaving default BGP timers. Your Cisco or Juniper router might default to 60 or 90-second hold times. You have to explicitly configure those aggressive timers. Number 3 is not testing failover. Bring down your primary tunnel intentionally and measure how long failover takes. I recommend doing this quarterly.
Let me make sure I've got this. AWS gives us 2 tunnels per VPN connection for redundancy. BGP handles the routing between them, but we need to tune the timers down from 90 seconds to 30 seconds or less. And BFD gives us sub-second detection if both sides support it.
Perfect summary. And here's my pro tip. Set up CloudWatch alarms on the tunnel state metric for both tunnels. You want to know immediately when a tunnel goes down, even if Failover is working perfectly. The metric is under the VPN namespace, and you're looking for tunnel state equals 0.
That's really practical. I'm going to check my VPN configurations right after this.
That's it for today's episode. If you found this helpful, please hit that like button and subscribe to the channel.
And share this with anyone running hybrid cloud environments. This stuff matters.
Thanks for watching the Network Ninja Cloudcast. Go check those BGP timers, and we'll see you in the next one.